Hey everyone, I just wanted to take some time to go over this Module 2 test review. It's going to look very similar to what you'll see on your test, so definitely spend some time watching this video, and if you have any questions after, make sure you just shoot me an email, and we can spend some time going over any questions you might have. All right, but first, for questions 1 through 13, determine whether the relationships being presented are linear, exponential, or neither. All right, so looking at this first one here, we see that it's f of x is equal to 5 times x minus 1 plus 7, right? And there's a couple things we got to think about. First off, if it's exponential, that means we should see a variable in the exponent, which we don't see that, right? So we know it's not exponential. And then if we kind of take a look at it, it looks like it's in point slope form, right? And if you remember, our linear equations, sorry about that, our linear equations are y equals mx plus b, right? That's our slope-intercept form. And then we also have that y equals m times x minus x1 plus y1. And that's our point slope form, right? And that's what this question number 1 looks like. It looks exactly like our point slope form, so we know 1 is linear. 2, we can tell right away there's a variable in the exponent, so we know it's exponential. And then the same thing with number 3. There's a variable in the exponent, so we know it's exponential. All right, number four is a little tricky because it does have an exponent, but the variable is not in the exponent. And when the variable is not in the exponent, then we know it can't be exponential. It's also not linear because it's not in any of our linear forms. So it's just neither. Then number 5 looks exactly like our slope-intercept form, right? Y equals mx plus b, right? Except it's negative 1/3 x minus 4, right? But it's still in that form, so we would say it's linear. All right, and then just as a little reference, right? Exponential equations are going to look like y is equal to a times b to the x. Remember, we want that variable in the exponent. All right, so number six we can tell is linear because it's in a straight line. All right, number 7, if we kind of take a look at number 7 and we look at the function values, they're kind of all over the place, right? It jumps up by 4, but then it goes down by 8, then it goes up by 12, right? And there's not really a pattern, and it's not being multiplied by anything either, so we know that it's neither. Number 8 says Ray's marble jar currently has 90 marbles. Each week he goes to the store and purchases 4 marbles to add to his collection. So we know it's going up by 4 each time. So it's linear because it's being added by the same number. Number 9 almost looks like an exponential graph, right? But an exponential graph is just going to look like an L, right? Or a J. This one kind of looks more like an S. So we would say it's neither linear or exponential. It's just neither. And number 10 is a good kind of explanation of why number 9 is neither, because number 10 is exponential, right? We kind of have that backwards L shape. It's that curved line, and we can see it never goes under that x-axis. So that's how we know it's exponential. All right, number 11, it's definitely going down, and we can see it's being divided by 10 each time, right? And we know dividing by 10 is the same thing as multiplying by 1/10. Remember, dividing by a number is the same thing as multiplying by the fraction of that number, right? So if it's dividing by 10, that's like multiplying by 1/10. And since it's being multiplied by the same number each time, it's exponential. Number 12, it doesn't look like that curved line like in number 10, and it's definitely not linear, so it is neither. Number 13, my sister opened a saving account for her money. She had $20 when she opened the account, and each month she deposits $10 into the account. Well, the $20 was the initial deposit, but then it's going 10. It's going up by 10 each month, right? So the common difference is that it's going up by 10. Since it's being added by 10 each month, we know it is linear. All right, let's keep going. So 14 through 21, it says identify the constant rate of change, if any. All right, so this is really asking, is there a slope? All right, so is there slope? Or is there a common ratio? Right, and we'll call slope m, and we'll call the common ratio b, right? Because that's what we use in the equation, right? Y equals mx plus b. Right, m is the slope. And then common ratio has to deal with exponentials, right? So that's that y equals a times b raised to the x power. So b would be the common ratio. So we're trying to find either the slope or the common ratio in any of these. Number 14, it's a linear equation, and the slope is going to be the number that's right next to the x variable. So the slope is this -7. So we'll say m is equal to -7. All right. Then we have number 15. The common, we can tell this is exponential because of this variable in the exponent, right? But the variable in the exponent tells us what the common ratio is, because the common ratio is what's being raised to that x power. So b in this case has to be 7. And looking at number 16, that looks like our point slope form. Sorry about that. That looks like our point slope form, right? Which again is another linear equation. I'll write it over here. That's that y is equal to m times x minus x1 plus y1, right? And again, we're looking for the slope. So that's that number. That's going to be the number right outside the parentheses. So that's going to be that 7 right there, right? 7 times x minus 4 plus 2. So the slope is 7. 17 is a slope-intercept form, so we're looking for the number right next to x, and that's going to be this 2. So the slope is 2. 18 looks really similar to slope-intercept form, and what we can actually do is we can distribute this, right? Multiply this 1/6 into the parentheses here. So we get 1/6 times x, which is 1/6 x, plus 1/6 times 3, which just ends up being 1/2. Right? But the big thing is we're still looking for the number that's right next to the x, which is this 1/6. So our slope is just 1/6. All right, number 19 is an exponential equation. It's that y equals a times b to the x minus 1, right? And it's still the same, right? The b term is what's being raised to the x minus 1 power. So our common ratio is 3. All right, now number 20 looks like our slope-intercept form, y equals mx plus b. The only problem is that there's nothing in front of the x, right? There's nothing attached to the x, which really means that there's a 1 attached to the x, right? We can always assume that something's being multiplied by 1. So we would say that slope, sorry about that, the slope is equal to 1. All right, number 21 is kind of a tricky one because it is in slope-intercept form, right? It's y equals mx plus b, but it's kind of out of order. This is really y equals b plus mx, right? The big thing to remember here is that the slope is always attached to the variable. Slope has to be attached to the variable. So that slope has to be 3 because 3 is what's attached to the variable. You can even rewrite this if you wanted, right? You can rewrite it as 3x plus 12, and it might make it a little more clear for you. So let's keep going. All right, so 22, 24, we're using the following information for. It says, Mrs. Spencer teaches first grade. She rewards her students that do a good job with stickers. Every day she only gives out 15 stickers from her 5,000 stickers book. Is this situation linear or exponential? Well, if she's giving out 15 stickers each day, right, that means it's going down by 15 each day. Since it's being subtracted by 15, we know it's linear, right, because it's a constant rate of change. It's not being multiplied by anything, so it's not exponential. It's being subtracted, so we know it's linear. All right, so write a equation to model the number of stickers left in the book per day, right? Since we're using linear equations, we can use that y equals mx plus b, where m is our rate of change and b is our starting value. Right, so since our rate of change, we kind of already found it here. It's going down by 15 every week, right? So we have y is equal to negative 15 because it's going down by 15, so it's got to be negative 15. X plus our starting value, right? And that starting value is this 5,000 sticker book because we're counting how many stickers she has left, right? And she starts with 5,000 stickers. All right, so we have the equation y equals negative 15x plus 50. All right, so how many stickers will Mrs. Spencer have after 60 days? Well, to find this out, all we have to do is plug in 60 for x, right? Because x represents the number of days. So we would have y is equal to negative 15 times 60 plus 5,000. All right, so if we do negative 15 times 60, we get negative 900 plus 5,000, and we get 4,100. All right, so bonus question. How many days until Mrs. Spencer runs out of stickers? Hint, when does she have 0 stickers? We have to think, in our equation, what represents the number of stickers, right? We know x represents the number of days, right? X is the number of days, which means y is the number of stickers. So we got to think, when is there going to be 0 stickers? So really what we're asking is, when is y going to be equal to 0? All right, and there's a couple ways you can do this. You could always guess and check. You can start plugging in numbers for x and see what you get until you get 0. Or we can solve this equation for x. Right, and what that means is that I want to move the numbers around this equation so that I can get x all by itself. And I can start by subtracting both sides by 5,000. Because if I subtract it from one side, I have to subtract it from the other. And that would give me one step closer to getting x by itself. Right, so I subtract 5,000 on both sides. I get negative 5,000 is equal to negative 15x. All right, then I see this negative 15 times x. I got to think, okay, how can I get rid of a times negative 15? Well, I can get rid of it by dividing by negative 15. And I can do that on both sides. And what I end up with is that x is equal to negative 5,000 divided by negative 15. which ends up being 333.3 repeating. Right? Or if you guessed and checked, right, you just plugged in a bunch of numbers for x till you got 0 as your answer, you probably would have gotten x equals 334. Because that's when it would be negative. So we know it would be past 0. So either one of these would work. Again, you can always guess and check. All right, for 25 through 28, Brady decides to start a collection of baseball hats that he can purchase online. Brady already has 2 baseball hats in his collection. After a year of searching online, he now has 6 hats total. The following year, his collection grows to 18 hats. This pattern continues for several years. Is it linear, exponential? Is it linear or exponential? Well, it's going from 2 to 6 to 18. So we know right away it's not being added by the same thing each time, because that doesn't add up, right? But we can tell that it's being multiplied by 3, because 2 times 3 is 6, then 6 times 3 is 18. Since it's being multiplied by the same thing each time, we know it's exponential. Right? Then how would we write the explicit equation for this pattern? Well, we know since it's exponential, we're going to use this y equals a times b to the x. Right? Now, the big question with this is, do we use y equals a times b to the x or y equals a times b to the x minus 1? And for this, I would say definitely start by making a table, which number 27, it actually tells us to create a table. So we're going to kind of skip ahead to that real quick. And we're going to have our x values and our y values. Right? It says Brady already has 2 hats in his collection. Then right after that, it says after a year, so 1 year of searching online, he now has 6 total hats. Right? So if he started with 0, that would mean at year 0, he had 2 hats. And then next it said, and after 1 year, he had 6 hats. Then after 2 years, he had 18 hats. All right, so that tells us we're dealing with the 0 term, which means we can just use this y equals a times b to the x, right? And we have to remember a is our starting value, right? It's the 0 term, so it's going to be 2, because that's how many hats he starts with. And then b is what it's being multiplied by each time. It's the common ratio, so it's being multiplied by 3 each time. So we have y equals 2 times 3 to the x. Right, and we can kind of keep this pattern going, right? We can go 3, 18 times 3 is 54. Right, we can go 4, and we get 162. Right, and all we're doing is we're multiplying by 3 each time, right? We're just keeping that pattern going. We could go farther if we want to, but you don't have to. All right, so next, what we can do here, let's see. We can graph this table here, right? And we can label it X and Y, right? And it kind of gives us a little scale to use. So we have X and we have Y. And what we can do, let's count by 5. So we got 5, 10, 15, 20 at the top. Then we'll just count by ones here. 1, 2, oops. Sorry about that. 3, and we'll only need to use 3. All right, so the 0 term is 2, right? So we should have a point at 0, 2. That's 0 in the x and 2 in the y. Excuse me. Then we're going to have a point at 1, 6, right? That's 1 in the x and 6 in the y. Then we're going to have a point at 2, 18. So 2 in the x, 18 in the y, that's way up here. Right, and then 3 comma 54 would be way off the graph, so we don't even have to worry about that. So we just connect our dots, and we have our graph. Sorry about that. All right, so we have our equation, we have our graph, and we have our table. After how many years will Brady have 2,000 bats? All right, or sorry, baseball hats. To do this, well, there's a couple things we can do. I would say the best way to do this would just to be to guess and check. All right. So we can say, okay, well, let's say we want to know what about in 5 years, right? We can use our equation, y equals 2 times 3 to the 5th power, because that'll tell us in 5 years how long, how many baseball hats will he have, right? And in 5 years, he's going to have 486. So we know 5 will not work, right? So 5 doesn't work. So let's try 6. So in 6 years, right, we're going to have 1,458. So we know we're close, but we're not there yet. So let's try 7 years, right? 7 years, he's going to have 4,374. So we know it'll take 7 years because that's how long it'll take to have over 2,000 baseball hats, right? 7 years. You can always use the table function in your graph in your calculator as well. It's kind of a shortcut for that. All right. Number 29, write the equation of a line with the slope of 5 and the point -7, 9. So for this one, we know we're going to be using point slope form because we're given a point and the slope, right? So we're going to want to use, and I'll write this over here, let's do it here, point slope form. Right, and point slope form is one of our linear equations, right? It's that y is equal to m times x minus x1 plus y1. And the good news is that this question here, it gave us m, right? It says it has a slope of 5. So 5 is m, and then it gave us the point -7, 9. So -7 is our x1, and 9 is our y1. So we just have to plug these values into our equation. So we get y equals the slope, which we know is 5, times x minus x1, so x minus -7, and then plus y1, so plus 9. Now we could leave it as this, but I like to clean it up a little bit because minus -7 is the same thing as plus 7. Subtracting a negative is the same thing as adding a positive. All right, so this ends up being our answer. Give me 1 second. Sorry, I just needed to grab water. All right, number 30. Write the equation of the line with the slope of -2 and the point 8, -3. So right away, we know we're going to use point slope form because we're given the slope and the point. The slope is -2, so m is -2. And the point, x1 is 8, y1 is -3. So we're just going to have y is equal to m, which we know is -2, times x minus x1, so x minus 8, and then plus y1, which y1 is -3, so we can just say -3. We have our equation. So 31, write the equation of the line that passes through the points 4 comma negative 1 and 5 comma 3. Now this one, it just gives us 2 points. So we need to find the slope in order to be able to write it in point slope form. Right? We could write it in slope intercept form, but we would need the y-intercept for it. And this one, it doesn't give us the y-intercept. It just gives us 2 points. So we're going to want to use point slope form, which means we have to find the slope. And if we remember our slope equation, right, slope, which we know is m, is equal to y2 minus y1 over x2 minus x1. Right, and lucky for us, it gives us these points that we can use, right? So 4 can be x1, negative 1 can be y1, 5 can be x2, and 3 can be y2. So we're going to do y2 minus y1, which is 3 minus negative 1, all over x2 minus x1, so 5 minus 4. All right, 3 minus negative 1 ends up being 4, and then 5 minus 4 ends up being 1, so our slope is 4. Then we just have to insert that into our point slope form, right? So we get y equals the slope, which we know is 4, times x minus x1, so x minus 4, plus y1, which y1 is just negative 1, so we can just write minus 1. So we have our equation right here. And again, we're just using point slope form, right? This form right here. And plugging in the information given into that form. So let's keep going. Let's do number 32 here. 32 is the same question. It's just with different points. All right, so we have 1 is x1, 4 is y1, 3 is x2, and 3 is also y2. So we need to find the slope. So we're going to do y2, which is 3, minus y1, which is 4, over x2, which is 3, minus x1, which is 1. 3 minus 4 is negative 1. 3 minus 1 is 2. So we get a slope of negative 1/2. So our equation is going to be y equals m, which we know is negative 1/2, times x minus x1, which we know x1 is just 1, then plus y1, and y1 is just 4. All right, so we have our equation there. All right, next, for 33 through 38, it says graph each of the following equations. All right, so for 33, it's given in y equals mx plus b. Where m is the slope, and if we remember, slope is the rise over the run, right? And b is our y-intercept. It's where it crosses the y-axis. All right, so if in number 33, b is 1, that means we're going to have a point where y equals 1. Then the slope is negative 2, which if we want to write that as a fraction, we can say that's negative 2 over 1. So our rise is going to be negative 2, and our run is going to be positive 1. So it's going to go down 2 and over 1. So we go down 1, 2, over 1. Down 1, 2, over 1. Down 1, 2, over 1. We should get a line that looks something like this. All right, now 34 is a little different because it's exponential. So we know what it should look like. It should look like that curved line, but it doesn't really give us too much information right in the equation. So we're actually, the best way to do this would be to make a table. Right? And if you have your calculator, you can use your calculator to make a table, Or we can just do it by hand, right? We can say, okay, if x is 0, right, what would y be? Well, we would do 12 times 1/2 raised to the 0 power. Well, I know anything raised to the 0 power is just 1, and I know 12 times 1 is just 12. So when x is 0, y is 12. All right, then I can say, well, what about when x is equal to 1? Well, if x is equal to 1, then we would just be doing 12 times 1/2 to the 1 power, and 1/2 to the first power is just 1/2, right? So 12 times 1/2 is just 6, right? And we can kind of see the pattern forming here too, right? We know the common ratio is 1/2, so we're going to multiply by 1/2 each time, which is the same thing as multiplying by 0.5. Right, so we can keep this going, right? If x is 2, we can do 6 times 0.5, and we get 3. And I think 3 points is enough, right? Because we're going to have 0, 12, which is way off the page. We'll give it a point kind of way up here. All right, we're going to have 1, 6, which is going to be over here, right? 1 in the x, 6 in the y. Then 2, 3 is going to be right about here. Right, and if we did keep going, right, we can kind of get a better picture, right? This would be 3, 1.5, which would be right about here. And we can connect these dots, and we can see the curve starting to form. So it's going to start curving down like that. And we have our graph. Right, so exponential, it's always best to make a table. Always best to make a table. And then just graph those points. 35 is a linear equation, right? It's in point-slope form. And the cool thing is that we can use that, right? Because it tells us y is equal to m times x minus x1 plus y1. So it doesn't necessarily tell us the y-intercept, but it does tell us the slope, right? The slope is -3 because it's in that m spot. And it also tells us x1, comma, y1, right? It tells us that point. x1 is -2, or sorry, not -2, it's just +2, because it's x minus x1, right? So x minus 2, we just get that +2, and then plus y1 tells us that y1 is just 5. So we have a point at 2, comma, 5. Right? Since the slope is -3, to write that as a fraction, we can say that's -3 over 1. So the rise over run, it's going to rise -3, so it's going down 1, 2, 3, and then over 1. It's going down 1, 2, 3, over 1. So we should get a line that looks something like this. So again, all we did, this one didn't give us the y-intercept, but it did give us a point on the graph, right? Because it's in point-slope form. So we just pulled out the 2 and the 5 as our x1 and y1, and then we knew the slope was -3 because that's in that m spot. All right, number 36 is an exponential. And for exponentials, we know it's best to make a table. Make a table. Right? So if we have 0 in for x, right, that would be 2 to the 0 power. We know anything to the 0 power is 1. When x is 1, so it would be 2 to the first power, we know y would be 2. When x is 2, that would be 2 squared, right? That would be 2 times 2, which we know is 4. Right? We can kind of see the pattern forming here, where we're being multiplied by 2 each time. So we could keep going, right? 3 would be 8, because that's 4 times 2. 4 would be 16. And we have our table. So we just have to plot it, right? When x is 0, y is 1. So we'll have a point right here at 0, 1. When x is 1, y is 2, so we'll have a point at 1, comma 2. When x is 2, y is 4, so we'll have a point at 2, comma 4. When x is 3, y is 8, so way up here. And we can see our curve. Good. Almost done. All right, number 37 is definitely in slope-intercept form, right? It's in that y equals mx plus b. So our slope, m, is 3, which we know is the same thing as 3 over 1. And our b, our y-intercept, is negative 7. So we're going to have that y-intercept at negative 7. So when y is negative 7, we're going to have a point there. Then it's going up 1, 2, 3 over 1. Up 1, 2, 3 over 1. So we have our line here. All right, then last one we're going to go through. We have it in point slope form, right? So that's y equals m times x minus x1 plus y1. All right, so we know the slope is going to be 2, which is the same thing as 2 over 1. Then our point, x1 comma y1, we get from the graph, right? x1 is going to be negative 6, right? Because it switches signs from minus x1 to plus 6. So we should have negative 6. And then y1 is negative 4, right? Because it switches signs as well. It goes from plus y1 to minus 4. So we're going to have a point at negative 6, comma negative 4, which is way over here, right? Negative 6 in the x, negative 4 in the y. Then it's going up 1, 2 over 1. Up 1, 2 over 1. So we should get a line that looks like this. All right. So that's all we have. These last ones, if you want to go through them, these are all the same problems, right? 1 through 4, it just repeats. If you want extra practice on these graphing problems, feel free. But that's all we have. If you have any questions, make sure you reach out and we can work through any problems you might be having. Thanks for following along. Have a great rest of your day.